Hey everyone, and welcome to another episode of Mrs. Ross Does Math. Today's lesson is for Algebra 1B. Our topic today is in Chapter 8, specifically focusing on factoring by grouping. Now, factoring by grouping is one of my favorite parts of this because it's a chance for us to tie everything we've learned together, and we're really going to be utilizing a lot of the tools that we've learned throughout this entire unit. Let's go ahead and get this started. So, when we're talking about factoring by grouping, we need to go over first our essential question. And that essential question for this unit is, how do you factor polynomials by grouping? Let me focus this a little bit better. All right, so before we go into this, we need to talk about how, or in this case, what is our vocab word for this week? And our vocab word for this lesson is factor by grouping. Now, factor by grouping is a method of factoring a polynomial with 4 terms where we will be factoring a common monomial from pairs of terms and then looking for a common binomial factor. So once again, when we factor by grouping, we are factoring a polynomial with 4 terms. This is going to be key for our success. Then once we have those 4 terms, we're going to be factoring a common monomial, that's another word for a common greatest common factor, or a greatest common factor, from each term or each grouping of terms from our binomial. Okay? So, in order to have this be successful, I do have some factoring by grouping steps for success. So let's go ahead and let's get this going. Our first step for success when we're factoring by grouping is that we want to draw a line down the middle. Okay. So again, I'm going to draw a line down the middle. If I have 4 terms in this polynomial, I'm going to go ahead and draw my line in between term 2 and term 3. Next, I'm going to find the greatest common factors. The GCF, the greatest common factor, for each group of terms. Okay, so once again, we're going to find the greatest common factor, or in this case, the greatest common monomial for each group of terms. Our third step is we are going to put a parentheses around the same. And ultimately, it's going to look like we have a parentheses around same, and we are going to have a parentheses around what's called the leftovers. So, you'll have 2 groupings of parentheses in your final answer. One will have the same terms, the other will be our leftover terms. And then lastly, we're going to multiply to check our work. Okay, so multiply to check work. So, utilizing the information from these 4 steps, we are going to go through and factor this polynomial together. Now, the polynomial we have here is 4n to the 3rd plus 8n squared minus 5n minus 10. My first step for success in factoring by grouping is that I'm going to draw a line down the middle. Now the middle is in between my 8n squared and my negative 5n. So I'm going to draw a line down that. There we go. Next, I'm going to set each grouping of terms separate from each other. So I have 4n to the 3rd plus 8n squared on my right side, or sorry, my left side, and I have negative 5n minus 10 on my right side. What I'm going to do now is step 2. I'm going to find the greatest common factor for each group of terms. Now, when I look at my first grouping of terms, 4n to the third plus 8n squared, the largest factor that they both have as a number is the number 4. So I'm going to take a 4 out of each. Now, they also happen to have n squared in common. Because they each have a set of n's, if I take away 2 n's from my 8n squared, my n's would disappear. And I can take away 2 n's from my n to the third, leaving me with just 1 n. So my common factor for my first grouping is 4n squared. Now in the parentheses, I'm going to write what's left over. Now that happens to be an n in my first term and a 2 in my second term. The reason why is because 4 divided by 4, those cancel out. And if I take away 2 n's from 3 n's, I'm left with 1 n. Next, 8 divided by 4 gives us 2, and if I have 2 n's here, I lose the 2 n's up there. Now I'm going to factor the other side. Now the largest number that they both have in common with negative 5n minus 10, that's going to go ahead and be negative 5. Now they both have 5 in common, but they also have a negative in common. So I'm going to pull out that negative. So I'm going to have negative 5. And then in my parentheses, what I'm going to be left with is an n as my first term. And then negative 10 divided by negative 5 is going to be positive 2. So I'm going to have n plus 2 as my other term. Now, I'm going to put this together. So, earlier we talked about having the sames, and we talked about the leftovers. Now, in this case, the same is going to be my orange. Okay. Now, I have one set of terms that is exactly the same, and that's this n plus 2. So that n plus 2 is going to be in my answer. So n plus 2 is one set of parentheses. Now in green is my leftover. My leftover is also my greatest common factors, and I'm going to label those as green. So my leftovers I'm now going to put together. So that's going to be 4n squared minus 5. Now this would end up being our final answer. This n plus 2 parentheses and 4n squared minus 5 parentheses. What I'm going to do now is I'm going to go ahead and double check this just to confirm my work. So I'm going to go ahead and create that box that we like. I'm going to have my n and my 2. I'm going to have my 4n squared, and I'm going to have my negative 5. Here we go. So I'm going to go n times 4n. That's going to give me 4n cubed. I'm going to have n times negative 5. That's going to give me negative 5n. I'm going to have 2 times 4n squared, which would give me 8n squared. And negative 5 times 2 is going to give me negative 10. Now, because none of these terms have a similar term, they don't have any commonalities, we're just going to write them as individuals. So once again, we get 4n to the third plus 8n squared minus 5n minus 10. And this matches our original answer up top. So therefore, the n plus 2 and the 4n squared minus 5 is our final answer. Now, before we get going into your assignment, I do want to go over a couple more example problems to help guide you through this process. Okay, so I'm going to go ahead and take my notes into my notebook. If at any point you need to go back through, rewatch this video, look through some additional examples, please go do that. If you have any questions, send me an email, leave me a comment, and I will get back to you as quickly as possible. All right, so let's go ahead and begin with our examples. So to begin with, we are going to start out by factoring 5x to the fourth plus 20x to the third plus 6x plus 24. All right, so starting out, I'm going to first begin by drawing my line down my two individual groups, separating them out. So now I have 5x to the fourth plus 20x to the third on one side. And on my other side, I have 6x plus 24. Now, I need to go through and identify the greatest common factor for each pair. So in this case, for 5x to the fourth plus 20x to the third, my greatest common factor is going to be the number 5, because 5 can go into 5 and 5 can go into 20. And the largest variable I can also pull out is x to the third, because I have x to the third here and I have x to the fourth there. Now, when I go 5 divided by 5, I get 1. And I have x to the fourth over x to the third. That's going to leave me with 1x remaining. So we're going to get x inside of our parentheses. Now I'm going to go 20 divided by 5, and that's going to give me 4. And then x to the third over x to the third would cancel out. So we get x plus 4 in our first parentheses. Now in our second parentheses, or in our grouping over here, we have 6x plus 24. Now, first we're going to look for the largest number that can go into both, and that happens to be the number 6. So I have 6 that I'm pulling out from each, and I can't pull out any variables because my 24 doesn't have a variable. So when I go 6x divided by 6, I'm left with the x, and then 24 divided by 6 gives me 4. Now, we're going to go ahead and put these together. So I'm going to combine my two groupings of x plus 4 into one group of x plus 4. And I'm going to have my 5x to the third and my positive 6 as another group. Now the reason why I said positive 6 is because there's no sign in front of this indicating that it's negative. So our de facto sign is going to be addition. So the other group, it's going to be 5x to the third plus 6. This will be our final answer. Now, because we need to go ahead and also check our answer, I'm going to go ahead and create a lovely little box down here to check that. And I'm now going to put x and 4 on one side, and I'm going to put 5x to the third and my 6 on the other. Now, multiplying these, 5x to the third times x is going to give me 5x to the fourth. 5x to the third times 4 is going to give me 20x to the third. 6 times x is going to give me 6x. And 6 times 4 is going to go ahead and give me 24. Now, writing this out, all of my terms happen to be identical to my original problem. So therefore, I know that the x plus 4 and the 5x to the third plus 6 is my final answer. Once again, because these two match, this is my final answer. Next, what we're going to do is we're going to break down one more problem, and that is this one here. We have 2w to the third plus w squared minus 14w minus 7. All right, so let's draw that line in between our second and third terms, separating them. And now let's write these out as two individual groupings. So once again, I'm going to have 2w to the third plus w squared, and I'm going to have negative 14w minus 7. Now, on my first set of terms, the 2w to the third plus w squared, because there's no number that both of them have in common, the only thing I can pull out here happens to be the variable. So I'm going to start out by pulling out a w squared from each, and what I'm left with is 2w plus 1. Now the reason why I say 2w plus 1 is because the 2 remains from the 2w to the third, and w to the third over w squared, when we're dividing these, gives us just simply 1w remaining. And then w squared divided by w squared, that gives us 1. Now on our other side, I have negative 14w minus 7. Now they both have a large number in common, and that is 7. And because they both happen to be negatives, I'm going to pull out the negative as well. So we're going to get -7. And then because there's no variable on the 7, we have to leave it at that. So what we're left with, again, is 2w plus 1. Because -14 divided by -7 is +2, and we have to bring down the w. And -7 divided by -7 is +1. Now we're going to put this together. So we'd have w squared minus 7 in one parentheses, and then we'd have 2w plus 1 in the other. Checking our answer, once again, we're going to draw the box. I have w squared and -7. I have 2w and 1. When we multiply this, we're going to get 2w to the third, -14w, w squared, -7, and once again, everything matches. So, because it all matches, we know that w squared minus 7 and 2w plus 1 is our final answer. Now, in your assignment, you may see a problem that has an equals 0 on the end. If that's the case, then what we're going to do is just simply set each one of these parentheses equals to 0, and we'd solve them individually. And that way, we're not only factoring, but we are also solving. So in addition to our notes, you also have an assignment, and that assignment is Chapter 8.8, Practice A. And that is this assignment here. So please make sure that your name, last name, and the class period goes on this. Now my name is Mrs. Ross, so I'm going to write that up top. Today's date happens to be 12/22, or whoa, no, that's the time, sorry. It happens to be, if notifications stop popping up, 4/20. So today is April 20th, 2020. All right, so taking a look at this, it begins with match the trinomial with its correct factorization. Okay, so for this set of questions, we're going to be matching 1, 2, and 3 with A, B, or C. Now, anytime we see a problem like this, 2x parentheses x plus 5 minus, and then x plus 5, there happens to be an imaginary 1 right there. So what we have, actually, is 2x minus 1, and then we have an x plus 5. X plus 5 happens in both A and C, but the minus only happens in C. So 1 is C. Next, for number 2, it says x plus 5 with 2x. We have a plus sign, and once again, there's nothing there, but there absolutely is, and that's that imaginary 1. And we have another x plus 5, so we have 2x plus 1 and x plus 5. That's going to leave us with A. Now lastly, we know that 3 is B because we have that imaginary 1 right here, and they both have an x minus 5. B is the only one with an x minus 5. So our answer is B. Now, for problems 4 through 12, they are asking you to write the expression. We're going to factor it. So just like up above, how it said x parentheses x plus 4 plus x plus 4, remember that in front of that x plus, that second x plus 4 where there's no number, there's always that 1. So because there's that 1, we're going to write x plus 1 and x plus 4 as our final answer. I'll zoom in so you all can see. Okay, so we get x plus 1 and x plus 4 as our answer. Now, some of them give us all of the numbers, like in number 8. We have a w in the front with a w plus 6 behind, and then we have a 3 in the front with a w plus 6 behind. We know that we're going to have w plus 6. Our other parentheses is going to be the w and the positive 3. So we get w plus 6, w plus 3. In numbers 13 through 21, you will be responsible for factoring these. This is the examples and the warm-up problems that I went through in our notes. So taking a look, we'd go ahead, we draw a line in between our second and third term. The largest thing I can pull out of 2x squared plus x is an x. So then I'd be left with x plus 1. The largest thing I can pull out of positive 3x plus 3 is the number 3. And again, I'd be left with an x plus 1. So putting this together, my final answer is going to be x plus 3 and x plus 1. Okay. When we take a look at number 22, 23, and 24, you're ultimately determining if the polynomial has been completely factored. So is it in its most simplest form? If it is, write yes. If it's not, write no and simplify it. Now in the case of number 22, we have x to the 4th plus x to the 3rd. That is not in its most factored form. They both have something in common that we can pull out as a common monomial. And in this case, that is x to the 3rd. So if I take out my x to the 3rd from each, I'm left with an x and then a plus 1. So I'm going to write no, x to the 3rd, and then x plus 1 following. This would be my final answer. For numbers 25, 26, and 27, we're going to go ahead and factor the polynomials completely. Please, please, please let me know what questions you have on this. And then taking a look at numbers 28 to 33, not only are you going to need to factor them, but you will also need to solve them. Please leave me a message, send me an email, leave me a message. Do whatever you need to do. I am here to help any way I can. This has been Mrs. Ross Does Math.